We also want to look at things like the cost to operate a car. It's more than just a car payment. So there's lots of things that you need to consider when you are purchasing a car, and one of those is the fuel options. Is it going to be a car that runs on gas, electricity, natural gas, diesel, hydrogen, hybrids? How is this car going to be operated? So because of all of these different options, fuel efficiency is now a much more complicated thing to think about. Miles per gallon that used to be the standard really isn't the same term. It's not as valuable as it used to be. So what we can actually do now is the EPA has these fuel ratings, and it is looking at the energy required to drive 100 miles. And that just gives us a little bit more of a standard way to make comparisons with cars. So if the EPA rating for a car is 24 miles per gallon, and we wanted to know the gallons per 100 miles used by this car, this calculation that the EPA is also using, one of the things that we can do here is use our skills from chapter 2 with dealing with problem solving. So here, miles per gallon needs to be thought of 24 miles per gallon. But we're actually going to set up a proportion where we do gallons per miles. That is how the calculation for the EPA is being done, where they're looking at the number of gallons it takes to drive 100 miles. So because of that, we need to switch that 24 miles per 1 gallon, do the reciprocal, make that 1 gallon over 24 miles so that we have our consistent proportions. Now we need to solve this, so we'll multiply both sides by 100. And so that's going to give us the number of gallons is going to equal 100 divided by 24, which is 4.17. So this rating that this car would have is that we needed 4.17 gallons per 100 miles. Other thing that we need to consider with the cost of operating a car is the depreciation. So the second you drive a car off of the car lot, your car starts losing value. And some estimates are given that the minute a car is driven off the lot, it's going to lose between 9 and 11% of the value. Now, just as a little side note here, if you were to purchase a car and not put any money down, the worst case scenario is that you would drive off the lot and have an accident where you've totaled the car. Now, I want you to think about something. If your car has lost 9 to 11% of the value the second or the minute that you've driven off this lot, and you immediately have a total loss, then you actually owe more on that car than the car is worth. And so often when you purchase a loan, they will offer you something called gap insurance, and that gap insurance covers the difference between what you still owe on the car and how much the car is worth. Now, you can prevent needing gap insurance by making a down payment that's at least 9 to 11% of the car value, so that when you do drive your car off the lot and it loses that value immediately, then you still owe less than what would happen with a total loss. So it's just something to consider. Now, this is a very, very rare thing that would happen, but you would hate for that 1 in however many thousand chance to be your turn to have that unfortunate event happening. So another thing to consider, though, is that after the first year, the car often will depreciate another 10%. And so that's just something to realize, that cars are not these investment properties or these good investments, because cars do lose a lot of value. And we just want to consider that when we are making a choice to purchase a car, because when you sell the car, you really have lost a lot of what that car was worth as you're driving it. Now, there are certain cars that depreciate more quickly, and so you can look at things like Kelley Blue Book and Edmunds.com to see which cars are going to hold their value more. Now, I'm the kind of person who drives a car until it just won't run anymore, and so I'm not quite as worried about the depreciation value. But if you're someone who likes to trade in your cars after a period of time, then it would be very useful for you to see which kinds of cars you're going to get the best trade-in value 5 or however many years down the road. So you've got your car payment, you've got to consider this depreciation, your fuel cost, but there's also insurance, maintenance, repairs, license fees. All of these things go into the cost of a car. So if we needed to calculate the cost of a car, we can use this example where a tennis coach purchased a new car for $32,500, financed $26,000 for 4 years with an annual interest rate of 3.75, and that gives a car payment of $584.15 a month. Now, if we knew that the license and registration was 1.2%, the sales tax was 6.75%, and the depreciation was 22%, and we could calculate all of that by taking the car purchase price, that $32,500, and multiply by 0.012, that will be that 1.2%. The 6.75% you would multiply by 0.0675, and the depreciation you'd multiply by 0.22, and you could do those calculations. Now, the fuel cost, assuming that you drive 14,000 miles a year, we know that the fuel efficiency for this car was 24 miles a gallon. And so we could calculate, if you're driving 24,000 miles and you get 24 miles per gallon, you would need to divide 14,000 by 24. And knowing that the average cost of gasoline is $2.56 per gallon, you could then multiply that result by 2.56 to see how much it'll cost in fuel driving. Now, there's interest that you're paying on your car loan. And so every time you do a loan, there's going to be some interest and some towards principal. So that interest is a cost that you're having to pay. Plus you have insurance and maintenance. So here are how you get those different calculations for license, sales tax, depreciation, fuel cost. And if you want to figure out how much that you've paid in interest, then we can actually use Excel to help us with that calculation. I created an Excel worksheet with all the things that I would need. So this is going to calculate the interest. I'm actually going to bold this so that I know that's what this worksheet's going to do. We first need to type in the annual rate. So let's suppose that it was a 3.75 annual rate, making 12 payments per year. And so how many payments are you going to make? So do equals 4 times the number of payments per year. So we have 48. Present value is going to be the amount financed. So we hit equals, and he financed $26,000. And then the start period, we want the first year. So we want month 1, and we want the last month of that first year, which would be payment 12. If you wanted the second year of this loan, the third year of this loan, you would just figure out which months that was in your 48-month term. Now, to get the cumulative interest, we're going to use the function built into Excel for cumulative interest, and that is equals CUMIPMT. So it's the cumulative interest payment, I think is what that is referring to. And so start your parentheses, you get the rate, then divide by 12. Make sure you always divide by 12 here to get the monthly rate, comma, the number of periods. This is how many periods are in the life of the loan. Excel needs that to do this calculation. Then the present value, how much you borrowed, comma. Then you have your start period, so the first month that you want to start calculating, comma. And then the end period, where you want to stop calculating. So for us, we want the first 12 payments, then comma. And then the type, it's almost always going to be 0, where the payment or where the interest is calculated at the end of the period. So typically it'll be 0 there. Close parentheses and hit equals, and we see that the cumulative interest is $870. And so for this monthly payment of $584, it's almost like a payment and a half additional that you've paid just in interest on the first year. Now I will let you note that it's not always this bad. If you're looking at the last year of the loan, so we're going from 48, and this would start at 37. The last year of your loan, you only paid $140 in interest. So as you pay down the principal, you can see that you don't pay nearly as much interest throughout the life of the loan. And that's where things like making an extra payment, things like that can help over the course of the loan, because you'll start paying down that principal quicker and you'll pay less in interest. So going back to this problem, we have our license and registration, our sales tax, depreciation, the fuel cost, the interest for 1 year, the insurance, maintenance. And so this car is actually costing you $13,521.27